Do you want to start a new development with Versal ACAP and EV12AQ600 ADC that uses the ESIstream serial interface? In this video, I will give you all the information you need to facilitate and accelerate your development, introducing ESIstream Versal package based on VCK 190 development kit. The package contains two design examples. One to loop back the ESIstream transmitter on the receiver, for instance, to create a communication between two Versal. And the second, that I will demonstrate, to start receiving samples from the ADC. I will show you all the steps to follow from project generation to signal acquisition. Of course, this solution works with space version of the components. I have to let you know that I'm using a modified version of the FMC AQ600 board hardware, as it does not support the maximum voltage of 1.5 volt required by Versal XP I/O banks. HD I/O banks directly compatible with the ADC AQ600 are also available to directly connect the control signal, but these banks are not available on the FMC Plus connector interface. A second revision of the board will be released, so please contact me if you want to order one to start your development on Versal. Now let's start the demo. First, you have to download the package. In your web browser, type www.easystream.com, click on Package, and then on Start your ESIstream project using an existing package. Scroll down until you find the right package and click on Download button. Then unzip it in your work directory. Now we have downloaded the package, we can generate the project using Vivado 2021.1. So click on Vivado. Then on Tools, run Tickle Script, and go to the AQ600 folder in the package. Select the Tickle script and click on OK. Wait for the end of processing. It can take a few minutes to generate the project. Once processing is complete, the project closes. Click on Recent Project View to open it. You can now generate the device image. It takes approximately 1 hour to complete. Now we have generated the device image, we are ready to load it in the Versal. Before powering on the board, check that all power supplies switches are on off position. Then connect the power supplies cable and the USB-C cable used by JTAG and UART to communicate with the dev kit. Now you can switch on the dev kit. At this stage, you can program the Versal. Click on Open Hardware Manager, then Open Target and click on Auto Connect. Versal Target appears. Right-click on the reference and click on Program Device and Program. Wait for the end of programming. There is a normal error message as the AQ600 board has not started. Click on OK. Now we have programmed the Versal, we can power on the ADC board. The hardware setup is now complete. We can launch the graphical user interface using a Python script. Go to the Python script directory in the package. and open a command window. type python space GUI.py space com plus the ID of the compor. You can find this ID in the device manager. Then press Enter to launch the graphical user interface. For this demo, I configured the ADC in one-channel mode and the ADC clock to 6.4 GHz to get the maximum sampling rate of 6.4 gigasample per second. With the ramp test mode, sending a known pattern to the FPGA, we can check that there are no communication errors. So let's look at how it works. First, configure the ramp test mode. Then program the PLL. Configure the ADC and synchronize the serial link. At this stage, the communication has started. Make sure that LEDs 3 and 4 remain off. If they switch on, it indicates a communication error. Now we know that the communication is working properly, we can configure the ADC in normal mode to start a signal acquisition. I'm generating with the signal generator a continuous waveform at 4.5 GHz on the ADC input 0. So, configure the ADC in normal mode, reset it, and click on OTP button to load ADC factory calibration set. Then, configure the ADC, select the cal set, and click on the synchronization button. Going back to Vivado Hardware Manager, you can now acquire sample data and save it in a CSV file. First, close and reopen the Hardware Manager to refresh the integrated logic analyzer. Click on the play button to start the acquisition. Then, export the CSV file in the same directory than the Python scripts. You can now display the spectrum of the signal in the first Nyquist and calculate the SFDR. Click on Plot Data, and in the command window, we can see the SFDR, here 57.2 dBFS. This brings us to the end of this video. You have learned how to get started with EV12AQ600 ADC and Versal ACAP. And so, you can see how it can help you to gain precious time in your development. Plus, the ESIstream license is free of charge and open source, so you can modify them as necessary. All the useful links are available in the description of this video. And if you need help or if you have questions, please contact me using the Teledyne hotline email address. Thank you for watching.